In this video, we're going to talk about the properties of exponents. It might also be referred to as exponent rules or laws of exponents. So just to get started here, what is an exponent? So an exponent is a little number high and to the right of the base number. So that kind of brings us to what is a base number. So here's my example here. We got a base of 3 and an exponent of 4. So you would read this as 3 to the 4th power. So the exponent here would be the 4 and the 3 is the base. Okay, so here it says what does an exponent represent? So an exponent is how many times a number is multiplied by itself. So in our previous example, 3 to the 4th, that would be 3 times 3 times 3 times 3. Throwing a variable in there with x to the 6th, same thing, means x times x times x times x times x times x. Okay. Another thing that we're going to talk about are what's called polynomials. So polynomials, we kind of have a little different way to do those here. So what we do is we're going to multiply the coefficients. So a coefficient is going to be the number before the variable. We'll see that in just a minute. And we're going to add up the exponents of the variables with the same base. Okay, so we're going to see examples of those in just a second. All right. So for 8th grade math, we are going to learn 8 rules. I know it seems like a lot right now, but we'll kind of break them down here in just one at a time. All right, so actually the first 2 kind of go together, and I like to refer to these as MADs. Okay, so rule number 1 or rule number 2 deal with multiplying and dividing. That's what the M and the D stand for. Okay, so here we have n to the a times n to the b. So what you're going to do there, that means if you have the same base, you're multiplying, then you're going to add the exponents. Okay, so this would be like if it was 8 to the 5th times 8 to the 3rd. All right, so then we do 8 to the 5th, 5 plus 3, so 8 to the 8th power. Okay, over here, this would be if the bases were the same, we're dividing, we're going to subtract the exponents. Okay, so this is MADS, stands for multiply, we add the exponents. When we are dividing, we subtract the exponents. Okay, third rule, I call power product or PPP. All right, so this is when I have a base with an exponent and then raised to another exponent, or basically we have 2 exponents in there. What we're going to do is we're going to multiply those 2 exponents. Fourth rule is like power of a product. Okay, so this would be if we have 2 different bases but the same exponent. It says that we can multiply the base numbers and keep the exponent. Fifth rule is the 0 exponent. Anything to the 0 power is 1. It's pretty simple. There is a little caveat to that. In just a second we'll see. But pretty much anything that has a power of 0 is equal to 1. Negative exponent. So if we have n to the negative h, all you're going to do is you're going to take the reciprocal of the base. So reciprocal means like, you know, if I had 1/5, it would be 5 over 1. So basically I'm flipping it. So I flip the base. So instead of n, I have 1 over n. And then I have my negative exponent becomes positive. So I take the reciprocal of the base and I make the exponent positive. Okay, power of a quotient. Quotient means I'm dividing here and I have a power to it. So all I do here is I basically distribute. I'm not doing the distributive property, but I'm just giving this exponent to the numerator and the denominator. So a over b to the c becomes a to the c divided by b to the c. And the last one, we have negative power of a quotient. So same thing here as 7, except for my exponent is negative. So all I do is I take the reciprocal, and then I make my exponent positive. And so then from there, I would revert back to rule 7, and this would be b to the c divided by a to the c. Okay, so let's look at some examples here. All right, so our first example, we have 6 to the 3rd times 6 to the 4th. Pretty straightforward example here. This would be an example of MADS. Okay, so this is going to be equal to 6, and then I'm going to add these together. So 6, 3 plus 4, so this is equal to 6 to the 7th power. Okay, same thing here, but with x's. So I'm multiplying again, so I'm going to add. So this is x, 7 plus 5, so x to the 12th power. Okay, so now here I have the power product. So I'm going to take the product of these 2 exponents. So 2 times 4 is 8. So this is equal to 3 to the 8th power. Not 38, 3 to the 8th power. Same thing here, but I have a variable. So y to the 5th raised to the 2nd. So 5 times 2 is 10. So this equals y to the 10th. Okay, a little bit different here. This would be like power of a product. So 2x is a product, 2 times x. Okay, so what I'm going to do here is I'm going to give this exponent to both of these terms. So this is going to be equal to 2 cubed x cubed. And I could simplify that if I wanted to. 2 cubed is 8. So 8x cubed. Okay, down here I have 2 different base numbers. Okay, so this would be also power of a product. So I'm going to multiply these bases. I'm going to keep the exponent. Okay, so 5 times 4 is 20. So this is going to be 20 squared. Or I could say that's 400. Okay, now here's our polynomial example. So we say with polynomials we want to multiply the coefficients. So 3 times 4 is 12. 3 times 4 gave me 12. I'm going to add the exponents. So x to the second times x to the fifth gives me x to the seventh. So 12x to the seventh there. Okay. All right, some challenging examples here. Okay, so number 1, get my paper back here. Okay, so number 1, we have x to the fifth times 2 to the fourth, x squared to the third. Okay, so what I'm going to do here is I'm going to give this exponent to both of these terms. So I can rewrite this as x to the fifth times 2, and now this would be like power product. So 4 times 3 is 12, so 2 to the 12th, and then times x to the 6th. 2 times 3 is 6. So now I can add these. Okay, so I get x to the 5th and x to the 6th. So I have 2 to the 12th, x to the 11th would be my final answer there. All right, number 2 here. This is another example of a polynomial. So there's a couple ways I could do this. What I'm going to do is I'm going to go ahead and multiply what's on the inside first. So 6 times 2 is 12. Add the exponents x to the 7th. All right, but I still have this 2 out here. So now this 2 goes to both of these parts. Okay, so this is going to be 12 squared and x to the 14th. And I could say that 12 squared is 144. X to the 14th. Okay. All right, now a little bit different here. It says write 16 to the 4th using a base of 4. Okay, so what I want to do here is I'm going to go ahead and write 16 to the 4th. So it's 16 times 16 times 16 times 16. But it says it wants me to use a base of 4. So I could think, all right, I'm going to change these bases to 4. Okay, but I want it to have the same value. So 4 to the what power equals 16? Well, that's 4 squared. Okay, so I got 4 squared. So now I can say, follow my MADS rule and say that I'm adding these. So 2 plus 2 plus 2 plus 2 is going to give me 4 to the 8th power. So my answer would be 4 to the 8th there. All right, so here's some other examples that go along with more of like negative exponents, 0 exponents, things like that. Okay, so I have y to the negative 6th. So pretty simple here. All I do is I take it and put 1 over y to the 6th. 28 to the 0, anything to the 0 is 1. Okay, now I have another MADS here. All right, so I have 7 to the 10th divided by 7 to the 5th. So I'm going to subtract here, so I get 7 to the 5th. Okay, down here, a little tricky. All right, I have 15 over y to the negative 8th. 15, I don't have to do anything to it. All I have to do is take my negative exponent in the bottom and move it to the top. So I get 15 y to the 8th. Down here, this would be power of a quotient. Okay, so I'm going to give the exponent to both the top and the bottom. So this is going to be 3 squared divided by 4 squared. And I could simplify that to 9 over 16. All right, down here I have negative power of a quotient. So what I want to do here first is flip that and make the exponent positive. So now I can write that as 5 cubed over x cubed. And I could simplify that a little further. If I wanted to, I could say 125 over x cubed. All right, and our last set of examples here. All right, number 1. Okay, we have 8 to the negative 4th, y to the negative 2nd, x to the 7th, and z to the 5th. Okay, so here I'm dealing with some negative exponents. So to do that, basically I could look at this right now as this whole thing is over 1. Okay, so all those things are in the numerator. Okay, so to make these exponents positive, I have to, if it's in the numerator, I got to move it to the denominator, and vice versa. If it was in the denominator, I got to move it to the numerator. Okay, so this, I'm going to leave x to the 7th up here because it's positive. I'm going to leave z to the 5th in the numerator because it's positive. I'm going to move 8 to the 4th down here and y to the 2nd because those were negative in the numerator. So to make them positive, I have to move them to the denominator. All right, next example. Okay, I can go ahead and give this exponent of 3 to both these terms, but then I'm going to have to do 16 to the 3rd. Or I could just simplify this. 4 over 16 is equal to 1 over 4. And I still have, y squared and y to the 5th. So all I did there was just simplify my fraction. Okay, so now I can give that exponent of 3. Okay, so I get 1 to the 3rd. And this is going to be y to the 2nd to the 3rd. So that's power product. So I get y to the 6th. And then this is 4 to the 3rd. And this is y to the 5 times 3, which is 15. Okay, so 1 cubed is 1. 4 cubed is 64. All right, and now I have y to the 6th and y to the 15th. So kind of a trick I could do here is look and I go, okay, where do I have more y's, top or bottom? Well, the answer is on the bottom. So my y goes on the bottom. And how many more y's do I have on the bottom? And so I would do 15 minus 6. All right, and I get 9. So I have 9 more y's on the bottom than I do on the top. All right, here. Okay, we're going to give the exponent to all of these parts. So I get 7 to the 5th, x to the negative 8th to the 5th, and a y to the 6th to the 5th. And we're multiplying all those. Okay, so I could keep that as 7 to the 5th. Now I have power product, so that's going to be negative 8 times 5. So it'll be x to the negative 40th, and then y to the 30th. Okay, but I can't leave a negative exponent in there. So I have to rewrite this as 7 to the 5th, y to the 30th, over x to the positive 40th. All right. Okay, so right here, all we're going to do is simplify here. So 9 over 5, it's already as simple as it can get. So I'm just going to leave that here, 9 over 5. So now what I'm going to do is I'm going to look at my variables. So I have more x's on top or bottom. That's going to be top. And I have 4 more. Where do I have more y's? Well, here I actually have the same amount, so those y's are just going to cancel each other out. And I have z's, more z's on bottom, and I have 5 more. So my answer is 9x to the 4th over 5z to the 5th. Okay, number 5 is a little tricky example here. It says negative 50 to the 0 power. Now notice this negative 50 is not in parentheses. So because of that, it actually means opposite of 50 to the 0. Well, 50 to the 0 is 1, and the opposite of 1 is negative 1. So if this was written as negative 50 in parentheses to the 0, then that would be equal to positive 1. All right, and last example here. This says 15y to the 0. Okay, well, we said anything to the 0 is 1. However, this is not in parentheses, so this is actually 15 times 1, because y to the 0 is 1, and that is equal to 15. So once again, if this was written as 15y to the 0, then the entire thing would be equal to 1.